Okay, we just finished a problem using long division, but now we're going to see how we can use synthetic division, something that's kind of fake, that's not quite like the division that we know. That's why, hence, it's called synthetic. And we can use synthetic when we have a binomial and one in which we can find our zero. Because to set up for synthetic, we use, it actually looks like an upside down division symbol. And inside this area here, you need to leave two lines. For the top line is going to hold the coefficients of what we consider to be the dividend, what we're dividing. So I notice I brought down just my coefficients, 3, -2, 1, and -5. And then the divisor, what it's being divided by, that's the factor. And so, well, actually not necessarily a factor, but that is the divisor, what it's being divided by. I find what is x here, and so I set the divisor equal to 0 and solve for x. So x in this case is 1, and I'm going to see, is 1 an actual 0 of this third degree polynomial? So to use synthetic, we start by dropping down the very first term. So I bring down my 3, and then understanding that what's on the outside is when I multiply, but anything on the inside is I add. So by dropping down the 3, on the outside I have a 1 and the 3. So 1 times 3 is 3. That goes on the inside. And because I'm on the inside, I'm going to add. So -2 plus 3 is a positive 1. Now I'm back to the outside, and everything down below is going to get multiplied by my x value 1 over here on the left-hand side. So 1 times 1 is 1. I'm on the inside again, so I add. On the outside now, 1 times 2 is 2. On the inside, so I add. -5 plus 2 is -3. Now I always get in the habit, when I find my last term, I box that out because then that represents that is my remainder. So knowing that I started with a degree 3, I did division using the synthetic method one time. So after I divided by one time, that degree is going to come down. So I'm going to be ending up with a quadratic. So once I divide once, my degree decreases by 1. And so these, since I started with the coefficients, doesn't it make sense that I would end with coefficients? So I end up with 3x squared plus 1x plus 2 with the remainder of -3. And I write that remainder just like I did before as -3 over the divisor, excuse me, of x minus 1. All right, let's do it again. Synthetic, utilizing my coefficients, 3. I don't have an x to the 4th, so I need to put a placeholder of 0. -1. I don't have an x squared, so I put a 0. 4 and -3. And I'm going to all divide that by what might be a 0, we'll see, -1. Start out, drop down my 3. I'm on the outside, so I multiply. On the inside, so I add. Outside, I multiply. Inside, I add. Outside, multiply. Inside, add. Outside, multiply. Inside, add. Outside, multiply. Inside, add. And again, my remainder, I do have a remainder. So therefore, what I could say is that x plus 1 is not a factor. -1 is not a 0 because I did not end up with 0 here, but we'll talk about that here in a second. So I've got a 5th degree polynomial. I divided one time, so I'm going to decrease my exponent by 1. So I end up with 3x to the 4th minus 3x cubed plus 2x squared minus 2x plus 6 minus 9 over my divisor of x plus 1. All right, so here we see we've got a remainder theorem. So if the polynomial is divided by some factor, then the remainder is going to be found by taking that 0 and plugging it back into that original polynomial. So for instance, I have 3x squared plus 7x minus 20. If I wanted to find the remainder of x minus 2, I'm going to take just 2. Where did 2 come from? By solving for x. And plug it directly back into that function. So 2 squared is 4, plus 3 is 12, plus 14, 7 times 2, 12 plus 14 is 26, minus 20 leaves me with 6. So the remainder, if I would do all of that with synthetic division, I would find my remainder to be 6. So if I want to find the remainder of this function, if I would divide it by x plus 1, so without going through all the division, I would just take the negative 1, again, and plug it in for x. Negative 1 squared is 1, so that's 3, minus 7, minus 20, so I end up with negative 24. Then now I have x plus 4, so I'd be plugging in negative 4 into that, and by going through and plugging in negative 4, I find that my remainder ends up to be 0. So what I can say is that x plus 4 is a factor. The other thing I can say is that negative 4 is a 0. That's where the graph would cross the x-axis, at negative 4, because my remainder is 0. The factor theorem is another important theorem, because just like here, is x plus 4 a factor? I can do that by plugging the value directly back into that particular function. So if I want to know if x minus 1 is a factor of this x cubed minus x squared plus x minus 1, I would just plug 1 into that function. So I end up with 1 cubed minus 1 squared plus 1 minus 1. 1 cubed is 1, minus 1, there's 0, plus 1 minus 1, it is 0. So therefore, I do know that 0 is a 0, which is kind of funny, lots of zeros. I'm sorry, I said that wrong. Therefore, not 0, 1. That's what I plugged in. 1 is a 0 of that particular function right there. I can also say that x minus 1 is a factor. So the answer to this original question is determine if x minus 1 is a factor. So the answer would be actually yes, it is a factor. Because I took the 0 of that, which is 1, x minus 1, set it equal to 0, solve for x, you get 1. And plugging 1 back in for x, you do get a remainder of 0. Now, how does this all come into play? Well, way back when you had were limited to only factoring and solving for a quadratic. Well, what happens if you have a higher level polynomial in which to try to find the zeros or try to find a factor for? How do we do that? Well, if you're given a function of a high degree polynomial, a third power, fourth power, fifth power, I should say something other than a quadratic, how do we go about to solve that? Well, the first thing we do is we recognize that if this is a fourth degree polynomial, that means we have 4 possible zeros. And if you would graph this on your calculator, you will see that you actually do have, I'm going to turn a light on here, you actually do have 4 places in which that graph crosses the x-axis. There is only one spot that actually looks like it crosses at an actual whole number. And if I go to my table, I will see that yes, the graph actually does cross the x-axis at, actually I have the wrong function in. Now that's kind of embarrassing. 2x to the 4th minus 7x cubed minus 8x squared plus 14x plus 8. I thought something looked a little odd. All right, so then here we will see that the graph does cross actually at a positive 4. There we go, that looks much better. Because my y value is at 0. But if you look at that, I have no other y values at 0. So how in the world am I going to figure out my other zeros that I need to find in order to solve this? Because if I can break this fourth degree polynomial down and get it down to a quadratic, I can solve a quadratic. I can use factoring methods, I can use square roots, I can use the quadratic formula. So if I can get anything down to a quadratic, I'm home free on trying to solve it. But the problem is taking a fourth degree or higher level polynomial to get it to a quadratic. That means that I'm 2 away, looking at my exponents, to getting to a quadratic. That means I need to have 2 zeros, because if I have 2 zeros, then I can use synthetic division to break it down to get it to that quadratic. So how do I find those 2 zeros? Well, I already did. I found x equals 4 just by looking at the graph. Okay, and double checking it with the table. But how do I know these others? Well, I can look at possibilities of zeros that I might be able to find, and I can find possibilities by taking the constant, factors of the constant divided by the factors of the leading coefficient. So the factors of 8, that's my constant, are plus or minus 1, because 1 divides evenly into 8. 2 divides evenly into 8, as does negative. Plus or minus 4 and plus or minus 8. So those are my combinations of all the factors of 8. And then if I would divide it by 2, the factors of 2 are plus or minus 1 and plus and minus 2. And then by looking, again, I'm finding all the possible rational zeros. I'm setting this up because this is a fraction. So 1 divided by 1 leaves me with plus or minus 1. 1 divided by 2 leaves me with plus or minus 1/2. 2 divided by 1 leaves me with plus or minus 2. 2 divided by 2 leaves me with 1. I've already got that. 4 divided by 1 is 4. 4 divided by 2 is 4. I'm sorry, 2. And plus or minus 8 divided by plus or minus 1 is plus or minus 8. And then when I take 8 divided by 2, I get 4, which I already have. So those are all my options. I do plus or minus because I could have -1 divided by -1, which is positive 1. So that's why the plus or minuses are included in that. So now these are all possible solutions. So now I go back to my graph. And I look at my graph and I think, okay, here it crosses between -1 and -2. Do I have anything as possible rational zeros that could be that? Nope. This looks like it could cross at -1/2. Is -1? Well, it is a possibility. So let me think that maybe -1/2 is a 0. The other 0 is between 1 and 2, not listed here. And then, of course, I've got my 4 that we already determined on the table to be a possible 0, or a real 0. All right, so I'm going to go with this -2, and I'm going to see if that actually works. So I'm going to set up my synthetic using my dividend up here, what I'm going to be dividing. So 2, -7, -8, 14, and 8. I'm going to start by dividing by 4. Doesn't matter which one you start with, but I know that 4 is for a fact. Drop down my 2, multiply on the outside, add on the inside, multiply on the outside, add on the inside. And since I know that it's a 0 for sure where it crosses the x-axis, my remainder better end up to be 0. Now, I don't start all over, I just add on, because this, in essence, is a cubic function that I have found here. So this would be written out such. And remember, I'm trying to get to a quadratic so that I can solve it. So I'm just going to tack on my synthetic just right underneath. Just look at how snazzy that is. Now, I'm not 100% that that is a 0, but we're going to check because we know it's a possibility. So if this ends up to be 0 right here, then I know for a fact that we've got ourselves where it crosses the x-axis here. So -1/2 times 2 is -1. That's 0. Anything multiplied by 0 is 0. Negative 1/2 times negative 4 is a positive 2, and look, it does. Negative 2 plus 2 is 0. So we were good at assuming that. Now I've got my quadratic. So I've got 2x squared, that's 0x, I don't need a right, minus 4 equals 0. So now that I'm in quadratic form, I can solve it. Let's pull out a common factor of 2. So I get x squared minus 2 equals 0 using square roots. I've got x squared equals 2. Take the square root of both sides. I get x equals plus or minus the square root of 2. So my zeros now that I know for sure were the 4 that I found from the graph, the negative 1/2 that I found from the graph, and then also using my possibilities of rational zeros, and then the 2 that I found using synthetic division. Now if I want to write this in factored form, so let's say that I factored this, I would say x minus 4, taking the opposite, putting it into a factored form, x plus 1/2, x minus square root of 2, and x plus square root of 2. Good job.